Hi there. In this video, we'll talk about the AP Pre-Calculus Math subject. We are still in Unit 1, Topic 1.1, titled as Change in Tandem, and we still need to cover some prerequisite learning. In the previous video, actually, we talked about an ordered pair, and by using ordered pairs, we defined a relation. Then we saw the domain of a relation, the range of a relation, how to draw the mapping diagram of a relation, and finally, we saw some different types of a relation, including one-to-one, many-to-one, one-to-many, or even a non-to-one. Now, we'll go forward into defining a special case of a relation, that of a function. So let's quickly begin by giving the definition. A function is a special case of a relation in which its input value is uniquely related to an output value. That is all. Let's go over again. It's a special case of a relation, so whatever holds for a relation, it's still valid here, and by that we mean that the function is a set of ordered pairs. We do have a domain, we do have a range. It could be classified in different ways, but we want that, since it's a special case, we want that to have two conditions, two strict conditions. First of all, its input value. This means that we need to use all input values. Then its input value should be uniquely related to an output value. So what would that mean? Any type of a relation, would it still be considered as a function? No. Let's see some examples. In example 4, we do see a mapping diagram of a relation. All of them are relations, in which from A is connected to 1, B is connected to 2. We still see that this is the letter gamma. This is like C. Let's call that C. C is not used at all. Is this still a function? No. How do we know? We did not use C. Hence, its input value condition was not met. So, no function here. It's still a relation, they all are, but not a function. Let's move to example number 5. From A, we go to 1. From A, we can also go to 2. From B, we go to 3. From C, we go to 3 again. Although I used all input values, so the first condition is met, I can see that from A, I can have a relation with 1 and the second relation with 2. So this means that the uniqueness part is lost. Once again, no function here. Let's go to the third example. From 0, we go to 2. From 1, we go to 4. From 2, we go to 4. From 3, we go to 9. All inputs are used. So we are fine with regards to this first condition. Each one of them is uniquely related to an output. Now, some might say, hold on, I can see that both 1 and 2 are related to 4. I agree. I hear that. But has anyone not allowed that? I mean, we use its input value. Its input value, isn't it uniquely related to an output value? From 0, 0 is uniquely related to number 2. 1 is uniquely related to number 4. 2 is uniquely related to number 4 again. 3 is uniquely related to number 9. That's all. It is a function. Just remember that in math, definitions are strict. If what we see is satisfied by that definition, then it's true. If anyone wanted to exclude that case, they would have stated that. It uniquely related, but they should be two different values. No one said that. Okay, so even if all the input values are related to the same output value, it should still be considered a function, as long as, of course, we also use all the input values. So that was all. Keep in mind that function, it is a relation, so it has a domain, it has a range, it can have a mapping diagram, but it is a special case of a relation. We need to use all input values. Each input value is uniquely related to an output. Before we are done with this video, let me tell you how I would remember what a function is when I was in your age. I would think of that as putting books on shelves. The books were the input values and the shelves were the output values. I can take all books, all the input values, and put them on the same shelf. It works. But I cannot take one book and split it, I should destroy that, in two different shelves. That's what I had in mind. I hope it helped. If, however, you still have any issues with what we've just mentioned, with the definition, or you have any questions, please feel free to share them under the video. As always, thank you for your time.